Perhaps illogically, we'll start with the last problem on the 0330 document. The exponential graph you're given is said to be the graph of y equals 2 to the x, and everybody seemed to be in pretty good shape with labeling the graph accordingly. Naturally, you have the point 0, 1, so here's your y equals 1, and then y equals 2, 3, 4, 5, and so forth as you move up. And then, of course, when x equals 1, y has to equal 2, so if y equals 2, x must be 1. So we go up to y equals 2, find the graph point, and project down, and that's where we located the x equals 1 point, because this graph was not at all labeled originally. Then we can use the fact that if x equals 2, y is 2 to the second, or 4, and we can come up to 4 and project down to find out where x equals 2. And using these equal spacings, it's a little harder to estimate quantities on the left, but we use the equal spacing on the left and check out that the quantities appear to be about right there. Okay, so we have a pretty good graph now of y equals 2 to the x, and we're asked to graph y equals 2 to the x plus 3. Now I have to say, nobody really had a clue what to do here. A little reminder, if x is replaced by x plus 3, what happens to the graph? Okay, well, still no real response. So, you know, this is something that came back in chapter 2. It's something that should have been mastered a long time ago, and now it's not there to be used, which means it won't be there when it appears on the test. So you really need to review that if you're in the category where you don't understand shifts and stretches and so forth. It's one of the central ideas of the course. Okay, well, in any case, the graph shifts -3 units in the x direction. Now that's a rule. You can memorize it as a rule. We've gone over why the rule holds. If you had done the problems that were assigned, you would have a much better idea of those rules, but I'm afraid from the amount of homework I've been getting that that's not being done, and that's going to be problematic. Anyhow, end of that lecture. So whatever, try to, yeah, I mean, you got to do the homework. Okay, you won't learn it if you don't. The graph shifts -3 units in the x direction for reasons I'm not going to go over here. And that means, of course, every point shifts 3 units in the negative x direction, 3 units this way. Now once we identified that the graph shifts this way, people did pretty well with it. About half the class shifted everything to the left. About half the class shifted everything down, but that's not the x direction, is it? The x direction would be this way. So if you shifted it down, you have the right idea, but remember which way x goes, okay? Okay, then, we also put this into function notation, another notation in which you should recognize this. F of x equals 2 to the x. So what function is 2 to the x plus 3? Well, it's f of x plus 3. So again, we're replacing x by x plus 3. Again, invoking this whole idea. To get the graph of f of x plus 3 from the graph of f of x, we've what? Shift every point. I never completed that because we digressed over to here. Shift every point -3 units in the x direction. Okay? Now we pose the problem, the function g of x equals x to the 2x plus 3 is in the form y equals a times 2 to the x for what value of a? Okay? Well, I leave you that to ponder. Okay, it's a good question, it's a good problem, and you really have the background to answer it. But I'm not going to address it right now. We'll probably come back to it at some point.